Okay, let's take a look at two more examples of integration by substitution. So the first example that we're going to take a look at here is they give us the first derivative. So they give us the first derivative and they ask us to find the original. So that means if we want to find f of x, so f of x is equal to the integral of this first derivative dx. So in this case here, if I want to go and find this first derivative, then what am I going to do? So I'm going to integrate 3x squared over x cubed plus 1 to the fifth dx. Now, sorry, my handwriting is quite small here. So if I want to go and integrate this, I notice that I will have to use integration by substitution. So what will I choose for my given substitution? Will I choose my numerator or denominator? So always choose the highest power, but then I'm not going to choose u as equal to this thing to the fifth. I will choose the inner function. So in this case, I am going to choose u is equal to x cubed plus 1. Then I will differentiate both sides. Du dx is equal to 3x squared. Now I will rearrange it to make dx the subject. And if I rearrange this, it becomes 1 over 3x squared du. Now let's go and rewrite our integral. So my integral, I have my numerator, which is 3x squared over u to the fifth times. Now instead of dx, I can replace dx with the following: 1 over 3x squared du. So 3x squared, they cancel out. So I am left with 1 over u to the fifth du. Then, if I integrate this, I am going to get 1 over 6 u to the, oh, sorry, my mistake here. Let's just go and erase this. If I wanted to go and integrate this, I would actually rearrange this to say this is u to the power of negative 5 du, just to make it simpler. Now, if I'm going to reverse my power rule, the power plus 1 divided by the new power. So the power plus 1 will give me u to the power of negative 4. Divided by this new power will give me negative 1 over 4 plus c. Now I can replace u, so it becomes 1 over 4. And in this case here, I can replace u with whatever I replaced u in the beginning. So let's go back and check. So u was actually x cubed plus 1. So I can replace this with x cubed plus 1. So this is f of x plus c. Now they gave us an initial condition. They said when x is equal to 0, then y is equal to 1. Alright, so if x is equal to 0, y is equal to 1. So I can replace x is equal to 0 and I can replace y is equal to 1. So y is 1 when x is 0. So this will become c. So 0 to the power of anything, 1 to the power of anything stays 1. So this becomes negative a quarter. So on the right hand side, this will become 1 plus a quarter is equal to c. And this will become 5 over 4 is equal to c. So now I have my c value. So f of x is equal to negative 1 over 4 x cubed plus 1 to the power of negative 4 plus 5 over 4. So there we have our answer. So this is the answer for C, and we have used our initial condition to find this value. Now let's go and take a look at another example. Here is another example. Find the exact value of this definite integral. So again, we have to choose a substitution in order for us to integrate this thing. So I notice here I have e to the something. I will not choose e to the something as my substitution. I will use this inside part from my substitution. In this case, x squared plus x minus 1. So du dx is equal to 2x plus 1. Now if I rearrange this, dx is equal to 1 over 2x plus 1 du. Let's go and substitute. So I can rewrite my integral 0, 1. Oh, sorry, 0, 2. There we have it. Now we will notice that again, with substitution, the first aim is we want to try to and eliminate. Oh, what am I writing here? I'm thinking about the previous question. E to the something, and now instead of dx, we're going to write 1 over 2x plus 1 du. The reason why we're using substitution is we want to try to eliminate, we want to try to cancel out some things so that our integral becomes simpler. Now, in this case, we arrive at e to the u du. But remember that my upper and lower bounds were in terms of x. So I've got two options here. I can either integrate it with my values for x, or I can rewrite it in terms of u. So let's create a separate part here. So for the first option, what I could do is I could say, if this is the value for x, let's rewrite our limits in terms of u. So u was equal to x squared plus x minus 1. So we can say, if x is equal to 0, then u will become 0 plus 0 minus 1 is equal to minus 1. If x is equal to 2, what is u going to become? U will become 2 squared, which is 4, plus 2, which is 6, minus 1, which is 5. So my new lower bound is minus 1, and my new upper bound is 5. So my new lower bound is minus 1, and my new upper bound is 5. E to the u du. So if I integrate this, it becomes e to the u, and I will use square brackets, and I still have my upper and my lower bound. So in this case here, it will become e to the fifth minus e to the negative 1. So there we have integrated it. Alternatively, what I could have done was, I could have left my integral in terms of x. Now, if I do this, take a look what I will do. I will integrate e to the u, 2 and 0, but then I will replace u with my original substitution. So in this case, x squared plus x minus 1. So here, x squared plus x minus 1. And we still have our upper and lower bounds in terms of x. And now when I'm going to evaluate this, again, I will arrive at e to the fifth minus e to the negative 1. And this will give me exactly the same answer. So it doesn't matter which route I choose.